right, just to make sure we all know our terminology. So the first couple pages are just review, but when it comes to types of angles, here they are. And acute is just less than 90 degrees. So an angle that's less than 90 would look something like this. Obtuse is greater than 90 degrees. So right, if this is your 90 here, right, if this is the baseline, that's your 90, obviously we're going to be past that. So that's going to be an obtuse angle right there. Right angle, that's exactly 90. A straight angle, when it comes to straight angles, imagine a line here, and you pick any point in there, and you kind of split it. If you were to measure the angle from here all the way to the other side, that's 180 degrees. Okay. And a reflex is just greater than 180. So if this is, I'm going to do it like this. If that's the point where we cut it, this would be the straight angle going that way, but we're going to go past it like this. So this angle right there is greater than 180 degrees. That's what a reflex. So those are your types of angles that you should already be familiar with. I'm going to continue. The following properties are always true, but I'm going to highlight this because later on we're going to justify whether or not lines are parallel. These cannot be used for that purpose, but it will allow you to solve for angles that at first sight are not there. Okay, so we have complementary, supplementary angles. Some of you might remember that one refers to angles that add up to 90, this one here. And the way to remember is it's right to give a complement. It's right to give a complement. So complementary, think of right angle, so two that add up to 90. So if this is 20, then y is going to be 90 minus 20, so that's 70 degrees. Right, so we can say, hey, this part right here, this second part is 70, so that one side split that 90 in half, not in half, sorry, but it split it up into 20/70. Supplementary, the shortcut to refer to supplementary angles, I'm just going to say, I'm going to often in my keys and whatnot, straight angle is equal to 180. Okay, that's what I'm going to write down to justify these ones. This one happens quite often. So if this is 30 degrees, let's say, and you want this one, let's say it's called angle X, well, you should very quickly realize that there's a 180 here. There's a straight angle, and it's being split by this. So we're just going to subtract the 30 from 180 and then conclude that X, angle X here, has to be 150 degrees. And I'm going to emphasize, right, there's our straight angle. And it's not always going to go sideways, guys. Sometimes it'll go in an angle. You'll see here again. It's not always just two angles along that straight line, but there you have your straight angle, and you've got 1, 2, 3 angles formed, right? So this is 31, and you will complete that like this, right? So you can tell that you have that little hat there along that orange line. So to find X here, we would simply go angle X is going to be 180 degrees minus 31 minus 24. So angle X is 125 degrees. So, and then I would usually justify, it's like, what did you just do? I would say straight angle is equal to 180. That would be my justification if I ever ask you to justify how you came up with it. So I'm quite certain this is review for you, but I just want to make sure we're all on the same page as we move forward. The next one, on page 3. Vertically opposite angles are congruent, they're equal. That's what congruent means. Okay, and this is the shortcut. I might go like this: vertically opposite angles are congruent, like this. It's an equal sign followed by a third wave. Yeah, I know you're thinking COVID, right? How many waves did we have there? But anyways, that's how I refer to this property. So you can write above or underneath congruent. This symbol for congruent in math is an equal sign with a squiggly line on top. So what are vertically opposite angles? It's essentially when two lines meet and they cross each other, the angles that are at this point, there are these two angles right here. We would consider those vertically opposite. Okay, these two angles are vertically opposite and they're the same. They're copies of each other. And it goes without saying that these two are also vertically opposite, but I'm just going to refer to that. And then this gets a little messy, as you can tell. But what I want you to remember is that, so for example, the 35, you have a pretty good feeling that it's vertically opposite angle. So you basically just say, let's see, do they share? Is 35 degree, is that angle that measures 35, the two sides that created, are those the same two sides on the other end? And here you can tell that, right, they share orange and pink, so x is equal to 35. Okay, so I'm going to go angle x is equal to 35 degrees. And I'm going to introduce another color here. So let's look at y here. I have a feeling that 29 and y are related. Here you can tell for sure because orange and green are shared to form 29, so is y. So we just say 29. Angle y is 29 degrees. How would you find angle z? Sorry, there's no opposite to it. This is where I want you to see. I mean, it's up to you how you want to do this. There are a bunch of straight lines here. So you could say, let's pick the orange one here, page 3. Look at this orange line. And if you want to, I'm going to do the hat thing here. Right? Along that orange, there are 3 angles, and we know that the orange line itself measures 180 degrees from end to end. So to find z here, I'm going to use a different approach. Angle z is 180 minus 29 minus 35, and you would have arrived to this in many other ways. You could have picked another line to make this happen. Oops, sorry. And so that ends up being 116 degrees. I used, sorry, what am I saying here? Straight angle is equal to 180. That's what I used there. For both of these, I used vertically opposite angles are congruent. That's what I used there. Sorry, it's a little crowded, and I will do this in more detail later on. but I want you to see, how things are related. Um, Maybe I will just show you on this diagram. I'll just highlight at least one pair of vertically opposite. If you're out of highlighters, I don't blame you, just leave it. But that's at least one pair vertically opposite, clearly visible, even though there's a bunch that are formed there. Next, sum of interior angles of a triangle is always equal to 180 degrees. So the shortcut is, watch this, sum of triangle is equal to 180 degrees. So whenever you're using that property to justify, you just need to state that. And here, sum of interior angles of a quadrilateral, four-sided, right, is equal to 360. So I say that sum of a four-sided shape is always going to be 360 inside. So to conclude, I talked about things that are always true on the previous page. So maybe I'll do that here. Summary. The following are always true. I'm just going to do this. Sum of triangles equal to 180. Sum of four-sided is equal to 360. Vertically opposite angles are congruent. And straight angle is always equal to 180. That's basically what I want to emphasize. Those are the ones that you're going to use for sure no matter what. Does it matter what the four-sided shape looks like? It doesn't. It's always 360. It could be a slanted, weird looking shape. If it has four sides, the interior angles add up to 360. Okay. So maybe I will highlight that. Let's keep going. Notation. This is always going to be, for some of you, this is going to be a bit of a head scratcher, maybe. I hope not. But let's say I wanna review three-letter angle notation. Okay. So for example, let's put some letters in here. Let's call this angle X. Let's call this angle Y. Let's call the top here angle Z. This one here. And the one right next to it, angle M. Those letters in there. So let's say I wanted to refer to angle X. Angle X can be written in two different ways using a three-letter notation. Because X is right here, you can't just say this is angle D. You can't do that. So what you need to do is, if this is where the vertex happens, that's basically like the middle letter. So then you can go A, D, B. So you can write it like this. Angle, sorry, I want to insert the angle symbol, so make sure you do that too. Angle ADB refers to angle X, but you can also read it backwards, correct? Do you remember that? BDA is the exact same angle. Notice that the D is always in the middle, right? So BDA or ADB is fine. And here's where I'm going to give you full permission to do this. If I ever give you a 3-letter notation, you put a letter, like assign a letter to it, and then just put it in your diagram. And from now on, I'm going to refer to it as angle X. Okay? So if I ever say, hey, find angle ADB, you're like, wait a minute, ADB. Okay, it's right here. Give it a letter and just go with it. Okay, it's a lot easier to know where to work with. So angle Y, how would you write that? And I want you to do the same with angle Z. Just a real quick, just a refresher. And angle M. I want you to write all 3 remaining angles using 3-letter notation while I update my attendance, okay? And there are your answers. All right. I think I will skip this for now. Sometimes I use it, sometimes I don't. I'll just leave it for now because it's gonna come up later. So we'll just continue on. So let's go to question page 4. So we're going to try to fill in this table. This is a very classic setup, by the way. So I give you a diagram. I'm going to ask you for angles, but you need to also justify how you got that. Okay. And I want you to tell me where you started. That's very important to me because it can be done various ways. So I'm going to start with angle X just because it's the very first one anyways, but you don't have to follow it in this order. Angle X. How would you find angle X in this case? I want you to zoom out and look at the triangle. We know 2 of the angles already. The third one can easily be found, right? So we're going to say that angle X is 180 minus 60 minus 70. And I know some teachers go minus 60 plus 70 in brackets. It's the same thing. Okay, so if you want to go with it, you go with it. So this would be 50 degrees. You put 50 here. And for justification purposes, we'll say that we've used sum of triangles equal to 180. You get full marks there. So this one is done. Some students find it helpful to actually write in. I use a different color just to show, right? Like we did that afterwards. And then you can travel anywhere you want. Let's do Y. Why not? Okay. So number 2, I'm going to focus on this. There's a hat right here. You see that? There's a straight line here. So I'm just going to say angle Y is 180 minus 85. And that's 95 degrees. So put 95 there. And my shortcut is straight angle is equal to 180 degrees. Bingo. So we put that in here, 95. Z, it's messy here, so I'm not going to do another hat here. But Z and Y are also along this straight line. You see that? But what do we call these two? Anybody remember when they share two lines? These are vertically opposite, right? Remember that? I'm going to use that just because I want to change it up. So that's my third angle. It's just 85 degrees. That's it. You just copy it and you say vertically opposite angles. I don't want you to have to write all that much, but I want to be able to have like a code. But if you want to write the whole thing out, you go for it. Okay. So that's 85. By the way, you can check if you did this right. What do you get when you add 85 and 95? 180, correct? Which you should have along this straight line. So you should be able to figure out if you're doing this right. Last but not least is M. I'm going to use my straight angle there as well. So just 180 minus 45, that's 135. Put the 135 in there, and then just say straight angle is equal to 180. So if I don't restrict you, just go with whatever you want to use. But sometimes I do tell you to use a different property every time, just so I can kind of test whether or not you understand the concept. Could I have taken this further? For sure. I could have watched this if I asked you for this angle here in this very corner. It's like, how would you do that? Well, I see a small triangle here. I don't know about you. So you can easily find this. You can easily find this. And then boom, sum of triangle to get this one, right? So just be prepared for it. All right, what do I have here? Parallel lines and transversal lines. Let's talk about that. This is where things are going to get, this is what you really want to focus on today, parallel and transversal lines. What are parallel lines? They never meet or intersect, okay? Lines are parallel if they never meet or intersect. How can you recognize it? Right, you can recognize by having the arrowhead on them. So for example, here, these two lines we consider parallel, and so would these two lines here. So we would say, sometimes it's just as a diagram, but we could say segment AB is parallel to CD. So this is how parallel is demonstrated. It's two lines kind of going parallel, forward slash. So we would say segment AB is parallel to CD. I don't think there's anything new here for you, but also EF is parallel to GH. And this is huge. If you're told that lines are parallel, that's actually going to be very important to us because we can find out a lot of missing angles with that fact. And I tell my students often, think of parallel lines as copies of each other. Do you remember parallel lines when you did the linear equations unit in IAPR? If they have the same slope, lines never meet, right? So we're not going to do that just yet, so don't worry about that. But that's where we were at. So I know it's a lot of information. That's how every unit kind of starts. So I apologize already. Next is your transversal. I can tell you that every line in your diagram could become a transversal that we're looking at, okay? A line that intersects two or more lines at distinct points, okay? So, but notice that a transversal line, I'm going to highlight that with a different color. A transversal line can also be a parallel line to another line. Keep that in mind. And we get, when you do this, when you look along the transversal, you have four distinct pairs of angles that we have names for. Okay. So in this particular case, there's only one transversal. It's this one. So I'm going to highlight that. That's your transversal line. It cuts two or more lines at a distinct point. Okay. We're going to travel along transversals a lot. We're going to pick a line and travel along it to find more angles. Okay. Let's keep going. Here they are. So these have to find their way to your study sheet. Make sure you highlight that. It's on page 5, study sheet. Okay. These are your four: corresponding, alternate interior, alternate exterior, and consecutive interior. So I will write this down. I'll first write down the definition. Two angles found on the same side of the, here's the word, transversal, comma, one is interior and the other exterior. And I'll show you this on the diagram. It's a lot easier to just look at it on the diagram. But that's what the definition of corresponding angles would be. Okay. Let's highlight our transversal. In this case, I just have one transversal. So to find corresponding angles, you have to stay on either side of the transversal. So let's say we stay on the left side because they're found on the same side of the transversal. One is interior, the other one is exterior. What in the world is that? Consider these two lines. You're making a sandwich, and these are the buns, right? So everything outside of it, anything out here, is considered exterior. Right? So both of these extremes will be considered exterior, and therefore anything in between the two lines that the transversal is cutting is considered an interior angle. And that's the same for all of these diagrams, by the way. So I'll just show you one pair here. So angle 1, that's an exterior angle, correct? It would correspond to this one here. If you have more colors, I'll show you one more. I will tell you that 4 and 8 are also corresponding. Okay, 4 and 8, you see that? 4 and 8 also corresponding. Check. They're on the same side of the transversal. One is inside, one is outside. But I'm going to go to the other side of the transversal and just show you that 3 and 7 would also be considered corresponding. But in fact, here, there are 4 pairs of corresponding angles. So here they are. I used up so much space here. Sorry, guys. I'm just going to say angle 1 and angle 5, angle 4 and 8, angle 2 and 6, angle 3 and 7. Those are your 4 pairs of corresponding angles. Remember that, or have it on your study sheet, and you don't need to remember. Next, my alternate interior angles. This word alternate, right? It means opposite. I want you to think of alternate as opposite sides of the transversal. So let's highlight this. What does it say? It limits you to interior only, so you have to stay here. There's no other way. Right? So alternate interior, I'm not going to define it. I'm just going to show you. Like this one and this one, those are alternate interior. That's one pair. And the other pair, I'm going to use a different color. I'm going to use green. Whatever you have, that's fine. So you have the pink ones and the green ones. Those are alternate interior. Maybe I'll just give you opposite side of transversal, both interior. Can I just say this not touching? Not adjacent. They don't touch each other. Because sometimes students think they're right next to each other, like 5 and 6. Those are not alternate interior. So angle 4 and angle 6, angle 3 and angle 5. Here we go. What about alternate? Again, that word should be, hey, that's opposite. Opposite side, right? So alternate what? Exterior angles. So again, let's highlight our transversal in this case. And both have to be exterior. So watch this. Maybe I should first clarify. This is exterior, and this is exterior. So we have to pick from the exterior. We cannot pick anything interior because the name says it all. So you have to pick this one, for example, 1. That is, then we cross the transversal and find this one here. These are alternate exterior now. Fun stuff, eh? I know. Can't help it. And then the 2 is alternate exterior to that 8 over there. So I'll say this. Opposite side of T, both exterior. Not touching. Because some students, I've had students say, hey, 1 and 2 are alternate exterior. It's like, no, they're not. They're touching. They should not be touching. Okay. You've got to travel across the interior on the other side. Okay, let's keep going. The last one, consecutive interior angles. So consecutive interior, watch this. This is interior, so we have to stick within the interior. And it's this, I'm going to use this color, pink maybe. It's actually these ones here, those would be consecutive interior, or these ones here. CIAs, I call these, okay? I forgot to mention which ones here on the side. So let's just write angle 1 and angle 7, angle 2 and angle 8. So corresponding, you've got 4 pairs. All the other ones, only 2 pairs. So here you would be angle 4 and angle 5, angle 3 and angle 6. Maybe I'll just say, right, they are on the same side of the transversal. Same side of T, okay? I don't know if you noticed, corresponding and CIAs, this one, they're on the same side of the transversal. Alternate exterior or interior, these two here, they're on opposite side of the transversal, and the word alternate is the one that gives it away. Okay? Crisscross. All right. Fun stuff, eh? On a Friday morning, you're wide awake, right? Need coffee or something. There you go. I will say this, very important actually. I was about to miss that, but these 4 angle pairs are always found along the transversal line. By 4, I mean like corresponding, alternate interior angles, alternate exterior angles. You'll find out that I'm pretty notorious for shortening because I don't want to write a whole lot when I do these questions, right? Because it just takes up a lot of time if you're finding 5, 6. But these are the 4 I mean by that. They're always present. They're always there. Okay. And here, now we're getting closer to the meat and potatoes of today's lesson, okay? Obviously, I needed to set this up so you knew what to call angles, especially these 4. Let's go over to page 6. So here I need your full attention for this one. I'm going to do only half of it today, and the other half we'll do on Tuesday. So let's go to 6. Yeah, you want to have your full arsenal of highlighters for this unit, okay? Angles formed by parallel lines. Conjectures. So we're going to focus on this today, and this we'll do on Tuesday. When a transversal intersects lines that are parallel, this is very important. Lines that are parallel. All of the following are true. Every single one of these properties would be true. Okay, watch this. Alternate exterior angles are congruent. Alternate interior angles are congruent. Corresponding angles are congruent. Consecutive interior angles are congruent. Oh, wait a minute. Supplementary, right? So that's, you need to remember that. These are congruent, but the last one is supplementary. They add up to 180. And here's my short version of this. If a T, I'll go transversal, cuts through parallel lines, comma, then alternate exterior angles are congruent. This is probably the best way to put it in your study sheet. It's a little shorter. Alternate interior angles are congruent. Corresponding angles are congruent. Consecutive interior angles are equal to 180. Okay, so that's important. This is what we're going to focus on today. We're going to take full advantage of this property. So it's basically just a translation of what I just told you above. Okay. But this is perhaps easier to like make it compact. All right. So here is a diagram drawn to scale. So that's still on there. In case you're still copying. And I need you to add a few things here to this diagram for it to make sense. We're good? Did I tell you? I told you about the snack bin, right? So if you ever need a snack to stay awake, you do that. All right, so here's I used GeoGebra. I don't know if your teachers in the past have used it. It's a free website that allows you to sketch. So I need you to understand that these two lines here would be parallel. And I also need you to understand that you have, actually a bunch of transversals here. Pay close attention to this. This line, if you travel along it, it cuts through 1, 2 lines, right? This could be considered a transversal. Okay, let's go off this and fly over to this side. Let's travel along this transversal here. This is also a transversal. It cuts through 1 or more lines. Let's fly over to this one. This could also be considered a transversal. It cuts through 2 or more lines, 2 for sure. So I want you to understand that transversal, any of them can become a transversal. Right? But when you have parallel lines, I like to make this a transversal, because this one will cut through these parallel lines. These are copies of each other, guys. Okay. So I need you to see something here. Let's highlight. Let's do some highlighting here. This angle right here, and this one right here. What do we call them? Out of the 4 names we have, what would you call it if you go to page 5? What name would you give these two? If you let's see if your notes actually work for you. Yeah, that's right. You see that it's corresponding? Same side of the transversal, and one is inside, one is outside. You see that? All right. So I will say corresponding angles, are they congruent? You see that they're congruent? Yeah. I'm going to highlight that with orange because that's what I. Is there more than one pair of corresponding angles there? You'd have to say yes. Yes, Mr. Dirksen, because 62 and 62 here, these are also considered corresponding, right? But we won't mention them all because it's too tedious. Let's look at another example here. Yeah, I will do this one. Pick a different color if you have. I'm telling you, this unit out of all units, if you could get some highlighters, that'd be great. What do we call these two? Other than Leo. Alternate interior. That's right. Yeah. So I will say, what do we notice about alternate interior angles here? You see that they measure the same? Yeah. So we know that they're congruent. And I'm going to travel to, oh no, I can do it right here. I can do it right here. What about this one? And let's travel over to here. What do we call those? Yeah, alternate exterior. There we go. And they're congruent, right? Do we see that? 62, 62. I want you to visibly see that this is actually happening. It's not, I'm not making stuff up, right? So, hey, we've just looked at that. And the last one I won't use highlighters for. What these are CIAs, right? This one and this one. These are CIAs. What do they add up to? Any guesses? You see that they add up to 180? CIAs are supplementary. So whatever I just told you, we just looked at it. This is drawn to scale, and we demonstrated that, hey, in fact, that is true. I'm going to give you a little, I'm going to foreshadow here. That's an English teacher moment, right? Do you think that if I could have just shown that one of these is true, that all of them would have actually been true? You think you can make that conclusion? Like if I, for example, if I just notice, hey, these ones add up to 180, do you think you could have then concluded that all of these are true? It actually turns out to be the case. Like if you can just show that one of these is happening, you are good to go. You can say, hey, like all of them will be true. Okay, let's travel to this side. I won't highlight here, I promise. This is transversal number 2 that I'm going to choose to travel along. Let's just see if this adds up. Are corresponding angles congruent here? Right? 100, 100, or we can say 80, 80, or we can go over here 100, 100, 80, 80. Corresponding are congruent. Alternate interior, they're the same. They're the same. And it stands to reason, right? If these lines are parallel, it doesn't matter where you cut it. Like you put a transversal there, you put one here, it doesn't matter. You're gonna come up with the same conclusion, right? Because it's a copy and it stays the same. And this gets me to my iPad moment here. I'm gonna show you this exact diagram. This is probably what I used for your notes. And look at, for example, the corresponding here, they're the same. If I were to move this transversal, doesn't really matter what I do with the transversal. Notice this, right? Alternate exterior, just look at the alternate exteriors here. The number will change because the transversal, but they're still always remaining congruent. Same with the alternate interior. Look at the alternate interiors. Doesn't matter what I do, they will always be the same, right? I could even move this side to side. It would also not change. Watch this. I can even make them collide, right? Cross right. That's going to happen down the road, by the way. So what I want you to focus on is pick a transversal and travel along it and try to find those 4 angles to help you out to solve for what's missing. Okay. All right. Let's keep going. We're going to skip 7 and 8 for now. That's coming on Tuesday. Go to page 9 with me. We're going to take it very easy for now, okay? I'm going to give you a few minutes to try this. And then we're going to step it up a notch before we go. I want you to notice it says calculate the unknown values and then show your work and justify your answers. So this is what you do, okay? You first and foremost want to look at, hey, these are my parallel lines here. So there's only one transversal for now. No, I'm not gonna, for this page, it just stays with one transversal. You can put a T there if you want. And if instead of a question mark, you can put an X there with a degree symbol, but that's the one they're asking us for. And if lines are parallel, what are the 4 promises that you're given? If lines are parallel, corresponding, both alternates, they're all congruent, and your CIAs are 180, okay? So what are these 2 angles called? Alternate, exterior. So this is all you need to do here. You're like, hey, because these lines are parallel, I know that these 2 are the same. It's 116 degrees. Why? Here's the justification. Alternate, exterior angles are congruent. That's all you need to say there. Full marks. Just impress me with you knowing why that is. That's right now what I'm focusing on a bit more. Let's do one more. Again, lines are parallel, and by the way, it's going to be the case for all of them. So the 4 things are true. What are these 2 called? Alternate. They're both inside. Alternate interior, right? So angle X, if you want to call it, angle X is going to be 100 degrees. Why? Because I know that alternate interior angles are going to be the same. I'm going to skip a few here. I'm going to go straight down to question 6. You're going to do the rest in a bit. I'm going to give you a couple minutes to give this a try. Go to question 6. Again, parallel lines. Okay, I have promises here that were made. This is a transversal. I'm going to choose to travel along. What are these 2 called? Consecutive interior, right? You can call them CIAs. That's just for us. Don't tell anybody else, okay? Secret. This is X. Angle X, you can't just say it's 101. You can't say that for CIAs. You have to go 180 minus 101, right? And that's 79 degrees. And you can say that because of consecutive interior angles are equal to 180. So that's the one time you have to actually do some math, right? You can't just say they're equal, and then you would actually make it false, right? And I will tell you this. There are instances if these symbols aren't there, you cannot go with those 4 promises, okay? That's only true if you actually have parallel lines. So that's gonna, down the road, I'm gonna change that a little bit on you. So I want you to, for a couple minutes here, try everything that we haven't done on page 9, and then also move on to page 10 already. I'll see how it goes. So you need to tell me the angle that's missing and why you determined that the value is what it is. Okay, so do that for now. You got to justify. I'll pause this here for a bit. So if you were able to come up with what I have, you're doing all right. Okay. We'll come right back to this. I want you to go to page 11. Because now, all of a sudden, go to page 11, all of a sudden you've got a few more lines in the mix, right? It's not going to scare us one bit. I only want you to ever pick one transversal to travel along. So the assumption is that the lines that look parallel today are indeed parallel. So for example, if you look at 12, I see a number along this transversal. So I'm going to focus on that one. And I'm going to ignore this one right now. Like if you could, I wish we all had an iPad, you just like delete it for a bit. I just want you to worry about this line. So if this is angle X here, we would find angle X by, these are what? CIAs, right? And you're like, what about everything else? Just focus on the two lines, okay, that are involving the one you're missing and the number that you're going to be using for it. Got it? So we just go 180 minus 134, and that's 46. And the reasoning, consecutive interior angles are 180 degrees. They equal to 180 degrees. Bingo. There's nothing, this other transversal here, forget about it. Just don't worry about it, okay? Let's do one more. Trying to think here. I'm gonna go with 15 here, question 15. Again, this is 90 degrees here. This is 90 degrees, page 11. You probably see that there's a transversal here and there's a transversal there. This one, this is a transversal. I'm just gonna focus on the one where the number is and that involves the one I'm trying to find. So I'm gonna pick this as the transversal to use at this point. Okay, this is my transversal. So if this is 90, what are these two angles called here? Mr. Dixon, I don't know, because this one here is messing me up right now. Forget about it. Forget about this one. Forget about the transversal you're not using. Think of just as if these two lines that it's cutting here and here, those are the only ones that exist. So let me ask you again, what are these two called? Consecutive interior angles. Yeah. So again, if this is X, angle X is just 180 minus 90. Angle X is 90 degrees. Why? Consecutive interior angles are equal to 180. So don't let the busyness of the diagram take away from the fact, that you're working with one transversal that you're choosing to travel along. And then maybe I should highlight the two lines that you're going to be worried about. It's the side that it cuts where the unknown is, and the other side that you're going to consider is the one where the number is attached to, the 90. Right? There's no number there. Yeah, it's a 90, right? So pick one transversal, look at the two sides that are being cut that you're interested in. That's my recommendation to you. I'm just going to say everything to page 12. I think you can. I was going to do all of the way to 14, but I'm just going to say 9 to 12. Yeah, we'll do the rest on Tuesday. So you probably did most of it already. I'm just going to say pages 9 to 12. Okay.